How interaction replaces integration. This is what you will learn in this course. Characteristics of integration. How interaction differs from integration. What data integration means. How interaction wraps integration. Interaction drives integration. About integration. In IT, we use a term integration when we combine code fragments into a program, combine programs into a component, combine components into an application or service, as well as when we combine applications or services into a solution or system. Why we use the same term? Do we really perform the same activities and carry out the same things in all these cases? Here is a definition of integration from a dictionary. An integration is the act of combining or adding parts to make a unified whole. Let's see if all aforementioned combinations make a unified whole, or are they only used in the same way? It is believed that integrated elements have to meet one or more of the following requirements. A. They share a common purpose or a set of objectives. B. They all observe the same standard or a set of standards, or they share a mediating intermediary. C. They were all designed together with a unifying purpose, objectives and/or architecture. D. They share some portions of a programming code. E. They share some special knowledge about the code, such as lower-level program interfaces, API, that may or may not be publicly available. However, if two elements meet one of those requirements, it is not enough to call them a unified whole. Particularly, the point A is typical for the loosest form of integration. If each element adheres to a common purpose and accepts the set of common objectives as its own, these elements are linked with each other tightly. At the same time, totally independent elements, which even are unaware of each other, may be exercised together for solving a task. Such elements do not share the task, but are used together. Is this an integration in your opinion? Point B is cumbersome. For example, all Java programs are written based on the same standards. Does this make them all integrated? Developers shall not agree with this. If two independent elements communicate with the same mediating intermediary, but for their own purposes are unrelated to each other, are these elements integrated? I do not think so. Points C, D, and E look like integration. Thus, an integration is really a means of constructing something as a whole, where elements or components of this whole are not fully independent. We say integration, but mean interaction. Some people insist that when two entities interact, they must be integrated. I could agree with this statement, but under one condition. Referred integration is only in the sharing of semantics and certain knowledge about an interaction. Unfortunately, in IT practice, this means of integration is exactly the one that is neglected. Here is a simple example. A passenger gets on a bus to be taken from the stop A to the stop B. It is assumed that the passenger has to buy a ticket from the machine installed in the bus. Are the bus and the passenger integrated? Is an action of buying the ticket means an action of integration? If integrated, a passenger has to share a part of a bus with the bus. Which part is this? If one creates a communication channel and a protocol between two applications, they can exchange data, but they are still used independently. Are these applications integrated? Does a notion of integration depend on the point of view? Those who use these applications together as a whole believe that applications are integrated. Those who use each application separately believe there is no integration at all. Here is another aspect of the same use case. Two independent applications with a communication channel and a protocol between them cannot and will not interact if used as is. This is because the applications are independent and do not need each other. So, for these applications to interact, at least one of them must be modified and become a consumer, while another will become a provider. Now we can talk about integration that allows interaction between applications. I have described a generic case and therefore may make a generic conclusion. For independent entities to become integrated more than by a semantic sharing, one or both entities should be modified for the purpose of integration, i.e., in order to interact. Can we integrate data? It is an odd question. Certainly we can, and we do it for many, many years. Well, do we? Apparently the right answer depends on what we mean by data. So far, we have found that an integration is about sharing semantical knowledge or making one entity a consumer of the work results of another entity. Let's take two use cases and try to integrate 1. 5 to 17 and 2. Mr. Joe Schmo to 5 Times Square, New York, USA. The only shared knowledge in case 1 is in that both data are digits. The case 2 shows only that they are English language expressions. I cannot integrate them. Can you? One would probably say that 5 and 17 are hours, for example, and they are integrated as clock markers. So why is it a clock and not prices for different ice cream bars? The data 5 and 17 carry an indication neither about the hours of the clock nor about price of ice cream. In another case, one can say that Mr. Joe Schmo lives at the address of 5 Times Square in New York. However, none of the given data has any indication of address or live at. When we come up with an idea of an ice cream price or a residential address, do we call it integration? We do, but this is the mistake. Here is nothing about integration. Assume we work with two financial systems. One of them has a value of £75 as a fee, while another has the same value as a price. When we integrate these two systems, we have to engage a special procedure that converts a fee of £75 into a price of £75. I can make only one conclusion based on this observation. Data integration cannot be a part of the data in contrast to applications. Data integration is an external transformation of the meaning of data. Moreover, a data integration is not about data at all. It is about metadata or data interpretation. This means that we have to deal with information instead of pure data and integrate information operating with the semantics. How, in this case, some people can say that two independent applications are integrated by a shared database. This statement makes any sense only if, first, these applications share not only the database, but also the data in that database. Second, these applications use the same data meaning or metadata provided by the database. Both conditions are mandatory because if applications work with the same data, this does not mean that the applications interpret the data in the same way. That is, the applications may use the same values stored in the same location being disintegrated. Here is a very common example. According to business rules, fees may not be obtained in all situations and thus may be null. However, a price never can be null. If a database contains null for a fee price's value, the application working with price might be ruined by this data. So sharing data without sharing or mapping semantics is unlikely to be recognized as an integration. Other manipulations with data, for example, moving data from one data store to another, cannot be qualified as data integration as well. Apparently, such moving cannot be qualified as a data store integration either. An accurate description of that data movement from an integration perspective is an integration between one data store and the data moving mechanism on one hand, and an independent integration between this mechanism and another data store on the other hand. In other words, if a data is moved from A to B by an external means, for example by an ETL system on its own initiative or trigger, we can say only that A and B are separately integrated in this external mechanism, but not between each other. Integration and connection are two different matters. Interaction wraps integration. With appearance of cloud computing and independent businesses of cloud providers, internal IT departments face a tough choice: either to reform their functional and operational models from development to dispatching clouds and survive, or to risk a massive annihilation and replacement by technology resources outside of the corporate or ownership boundaries. With a positive view, I expect a shift in corporate IT mindset towards cooperation with clouds and outsourcing. This places a demand for integration on the front stage of IT concerns. A few examples of such concerns are: 1. An integration between external technical resources and remain internal systems in the light of internal systems steadily becoming external. 2. An integration between external technical resources that cannot or do not want to integrate with each other. 3. An integration between cloud realms provided by such big vendors as IBM, Oracle, Microsoft that have advanced but proprietary internal integration. 4. An integration between cloud infrastructure and cloud functional resources. Since any cloud provider is in a position of offering elements of software infrastructure, e.g. security, and charge consumers for this, I expect a long-time disconnect in this area based on a conflict of financial interests between different cloud providers. At the same time, clouds have brought a sort of unification of integration technologies and protocols. For example, HTTP, web services, REST, XML over HTTP, SAML, XACML, and alike. Even traditional vendors of data are in the process of adapting the standardized technologies. This means that the integration technology becomes a commodity, while the focus of cooperation with cloud-based resources such as SaaS, IaaS, PaaS shifts onto interaction models. If system A and B are just interconnected, they are not integrated yet. Only when A and B agree on interaction and information exchange, we can say that they are integrated. Consumers are interested in the interaction between applications or systems, i.e. their collective work. Physical connectivity, which is mistakenly called integration, is only an enabler of interaction. Interaction drives integration. In an environment where integration technique sublimates to a half a dozen methods, a variety of business scenario and protocols require to put more attention on the interaction between entities than on the mechanics of the integration. This is where the interaction patterns come to help us. Specifics of interaction patterns is in that they define what should be done for the interaction rather than how it should be done. This leads to a two-dimensional specification of patterns. In one dimension, we separate synchronous interactions from asynchronous. In another dimension, we separate explicit interactions from implicit. In the table, I show several interaction patterns in aforementioned classification. Several patterns in the table appear as synchronous and asynchronous because they may be implemented in both ways. I'd like to refer you to widely available literature that explains such patterns as request-response, ETL, network socket, FTP, command and IP RPI. In this course, I will focus on distinctive characteristics of adapter, agent, smart proxy, mediator broker, gateway, data store sharing, scheduler, federation, covenant, and guaranteed delivery patterns. With an exception of covenant and guaranteed delivery, all other enumerated patterns define a precise third article involved into interactions between A and B entities. So, adapter, agent, smart proxy are patterns that associate specialized dedicated article to either A or B or to both. The core difference between adapter and agent is that the former is passive and reactive to the incoming requests, while the latter may be proactive and can initialize the interaction. A smart proxy is similar to adapter, but has additional ability to choose the integration channel, especially for the responses in the interactions. The mediator broker, gateway, data store sharing, and scheduler patterns assume a standalone article in addition to A and B. This article in the mediator broker can not only accept and direct interactions request-response messages, but also knows the logical rules where these request-response messages should be directed to. A gateway pattern uses an article as an informational directory or a gate from one realm to another. For example, a gateway service described in the e-course How to Save on Security in Clouds, a gateway service, propagates service offers from one opaque security realm to another. A pattern of data store sharing requires a shared article of a persistent data store type. A scheduler pattern assumes an additional article that can trigger an execution of all or some of interacting elements. A pattern of federation is a pattern of patterns. The third article in mediator broker, gateway, and scheduler may be realized as a federation of providers. This may be useful in the cases where one instance of, for example, a broker is not sufficient for the amount of interactions, while several interconnected instances can solve the task. For all interaction patterns described so far, actual integration technology is arbitrary. For example, a mediator pattern may be implemented using synchronous programming API calls, RPI, asynchronous messaging, request-response calls via sockets, and web service or XML over HTTP. A conciliator pattern addresses the cases where the granularity of request and response messages do not match each other. This is typical for RIA and business service. In RIA, the granularity of end-user activities in the user interface and related request is much higher than the granularity of interfaces of business services that have to process users' requests. A covenant pattern requires A and B to agree on the terms of interaction up front. This includes the protocol of interaction with all necessary initiation, regular and exceptional, failover, and alternative messages. A guaranteed delivery pattern is known and realized in the reliable messaging specification. In essence, this pattern requires that the implementation may be able to protect the request-response message in the case of any failure of integration infrastructure and, upon a restoration, be able to continue the transition and deliver the message to the destination. What you have learned. An integration has to have at least one of 5 listed characteristics defining what is shared between integrated parties. If a third party initiates and provides an information exchange between A and B, they are not integrated. Interaction is an action enabled by integration. Interaction and interaction patterns make integration meaningful. Data integration means integration of data's meaning, semantic or metadata. Interaction patterns realize a function of integration, but are integration technology agnostic. Thank you. Please allow me to thank you for your time and attention. I hope you have found useful information in the course. If you have any related questions, please post them in the related forum on the same website, and I will do my best to respond as soon as I can. Also, you are very welcome to post your opinion and considerations about the course in the same forum. If you have a consulting proposal with regard to this or another course or the blog post, please use Contact Me instant messaging on the same website to contact me directly. Thank you again, and good luck.